Hello everyone, this is Muhammad Omar. Today we are going to talk about power series. So first of all, we take start by definition. What is power series? Power series. Actually, power series is an infinite series of the form, summation, and start from 0 to infinity Cn x minus a raised to power n. So this is a power series centered about a. A is called as its center. This Cn is a coefficient and x is a variable. So this is a power series centered about A, and this is a power series in a variable x. N is a power here. This is a power. And this is the summation symbol. And it goes 0 to infinity. If center A is equal to 0, then power series will become n equal to 0 to infinity Cn x raised to power n. This is the power series in variable x center about 0. So let's we discuss about that how we find the center of any power series. Like if we have given a power series, how we will find a center of this. Uh, for example, if we take mission and start from 0 to infinity mission and start from 0 to infinity, and we have, let's say, Cn x minus 5 raised to power n. And another example, we will take n equal to 0 to infinity, and here we have Cn 3x minus uh, okay plus 1 raised to power n. Or C part, we can take let's say summation and start from 0 to infinity xn over n factorial. Or D, one more, like summation and start from 0 to infinity, and we have let's say for example we have 4x, uh, let's say 4x minus 1 raised to power n over n square. So this type of case, what we will do in this case, for finding center, what we have need to do, we will consider this part, like we will consider this part and set it equal to 0. So x minus 5 will be equal to 0, and we will solve for x. So x is equal to 5. Actually, this is a power series center about A is equal to 5. In the same way, when we talk about this B part and we have need to find the center, what we have need to do, we will set this part equal to 0, 3x plus 1 equal to 0, and then we will solve for x. So in this case, it will be equal to 3x will be equal to minus 1. And when we divide 3 on both sides, we will get x is equal to minus 1 by 3. So we will say that our A in this place will be minus 1 by 3. So this is the center. So we will say that this is a power series center about minus 1 by 3. And if we talk about to find the center of this one, so you can see that uh, if we want to write it as, we can write x minus 0 raised to power n. So in this way, our x will be equal to 0. This means that a equal to 0 actually. So this is a center of this power series. So we can say that this is a power series center about a is equal to 0. And if we have need to find the center of this series, how we will find? Again, we will set it out this part equal to 0. So 4x minus 1 will be equal to 0, and we will solve for x. So it will be 4x will be equal to 1 and x will be equal to 1 by 4. So this means that our center will be 1 by 4. So we can say that this is a power series center about a is equal to 1 by 4. So this is a way out how we will find the center of any power series. After that, we will discuss about that, like if we have any power series, so how we will find out the uh, interval of convergence and radius of convergence. There are two things: radius of convergence, and second thing, interval of convergence. Interval of convergence. So radius, if we talk about radius of convergence, this means that when we find the center, for example, uh, if we draw a real line and we draw a center, let's say this is a center. So this center to that point of, like, when we find the interval of convergence, so it will be something like that. So this point of center to boundary of interval of convergence, this is called as our radius, and it is denoted by like that r. So actually radius of convergence uh, is the distance from a center to the boundary of interval of convergence. And this is the distance, the distance from a center, from a center, from a center to the boundary of, to the boundary of interval of convergence. And it is denoted by r. And if we talk about interval of convergence, this means that all those values of x, like if this is a, you can say that power series in variable x. So all those values of x which we substitute here, and our power series will become convergent. So this means that interval of convergence, if we talk about the interval of convergence, this means that the set of all those values of x for which the series is convergent. The set of all those, set of all those values of x for which the series is convergent. For which the series is convergent. So it can be represented by like that. It will, like, keep in mind when we talk about interval of convergence. So if he says that you have need to find open interval of convergence, this means that you have need to just find open interval. And if he says that you have need to find interval of convergence, then you have also need to check it out that these endpoints are the part of the interval of convergence or not. Like if this is a part of interval of convergence, then you will use close brackets, and if not, then you will use open brackets. So for example, if we want to discuss, if here is a center, and let's say we find the interval of convergence, any number, let's say c to d, and c will be somewhere here and d will be somewhere here. So if this is open interval, we will represent it by like that. So there will be an open circle. And if there will be a close interval at any side, so let's say this interval, let's say we have a interval of convergence something like that, so we will represent it by closed circle here and open circle here. And if we get interval of convergence something like that, then this means that this one will be open circle at c and close at d. And if we get both are like that, so this means that we will get close circle on both. This means that endpoints also include. This means that this endpoint include, like this endpoint include, but this one not. This endpoint include, but this one not. Both endpoints are not include. Both endpoints are include. Now we will learn about that how we can uh, we'll learn about that how we can find the radius of convergence and interval of convergence. So for this, let's say we take one example. For the before going ahead, let we discuss about that three cases that we always get in case of solving, in case of finding interval of convergence and radius of uh, convergence. So for check it out that series is convergent or not, we will use ratio test. Keep in mind, when if limit n approaches to infinity, we apply ratio test something like that, and we get its answer equal to 0. This means that our radius of convergence will be equal to infinity and our interval of convergence will be equal to r real number. This means that uh, our power series will be converged for all values of x, and our radius of convergence will be infinity. This means that something like that. Let's say your center is a here, so radius of convergence from all infinity, and you can take any x value from here, and if you put that x value into your series will be converged. Second case, if you apply a ratio test like that and you get answer instead of 0 infinity, then what will be the radius of convergence in this case? So in this case, your radius of convergence will be equal to 0 and your interval of convergence I will be equal to just single number, that is your center. And if you plot this on number line, so it will be only this is the point A where the series converge. Only this value of x is equal to this center, your series will be converged. All other values of x, your series will be divergent. So actually this is a case of divergent, like series is divergent except center. And the third case is if we apply our ratio test a n plus 1 over a n. If we apply this test and we get something like that, 1 over r x minus here is a. So in this case, we will solve this like this expression, like this will be our radius of convergence, and we will solve this expression x minus a less than r. That will give us the interval of convergence, open interval of convergence, open interval of convergence. And if we solve the for this will give us the open interval of divergence, open interval of divergence. So whenever we apply ratio test and we get something like that, so in this case we have need to solve this inequality. And if we want to solve, if we open this mode, we know that that will become x minus a less than r, and this will be x minus a greater than minus r. And if we want to find x, what we have need to do, we have need to add here plus a in all. So when we add a, we will get here, like this point we will get a minus r, and that point we will get x that is equal to r, and this will be less than equal to r plus a. So this means that for third case our radius will be equal to r and our interval, open interval of convergence, this is open interval of convergence, keep in mind, that will be equal to a minus r comma a r a plus r. This is the open interval, but don't forget to check endpoints. In this case, in third case, we will also check endpoints. Endpoints. Keep in mind, again, I am saying that if he says that you have need to find open interval of convergence, this is fine. But if he says that you have need to find interval of convergence, this means that you also have need to check it out that is the given series converge or diverge at the endpoints. Okay, so we will take some example and work on it so that we will better understand this concept. For example, if we take we have, let's say, summation and start from 0 to infinity, and instead of 0, let's say if we have and start from 1 to infinity, xn over n factorial. So in this case, see that how we will solve, how we will find out the radius of convergence and interval of convergence. First of all, what is the center of this series? We can see that the center of this series is a is actually equal to a is actually equal to 0. This power series center about 0. Now, for interval of convergence, we know that we have need to apply ratio test. So an will be equal to an xn raised to power x raised to power n over n factorial. And if we find n plus 1, what we will do, we will replace n by n plus 1, so it will become x raised to power n plus 1 over n plus 1 factorial. After that, we will use this formula, limit n approaches to infinity, a n plus 1 over a n. So that will be equal to limit n approaches to infinity. What is a n plus 1? This is x n plus 1 over n plus 1 whole factorial. And if we divide it by this and we want to write it as in a multiplication form, so that will become actually n factorial over x raised to power n. Keep in mind, if you have a over b divided by c over d and you want to write it as in a multiplication form, so this will be actually equal to a over b will be as it is multiplied by, you will take the reciprocal of this denominator expression d over c. So I did the same here. We have a division form. We have you can consider a over b this and c over d this. So I directly take the reciprocal of this expression, reciprocal of this second expression here. So when we cancel out the common terms, so what we will get, see that limit n approaches to infinity. And if we want to write it as x raised power n plus 1, we can write it as like that, x raised power n x divided by, we know that if we open this n plus 1 factorial, it will be equal to n plus 1 times n factorial multiplied by n factorial over x raised power n. So here we can see that x raised power n will be cancelled out with x raised power n factorial will be cancelled out n factorial, and we will get limit n approaches to infinity mod x over n plus 1. And we can also write it as mod x because x don't have any power of n, that is why this is independent of n, so we can take it out of the limit, and limit n approaches to infinity 1 over n plus 1. I remove the mode here because we know that n start from 1 to infinity, so this is a positive number and mode of a positive number also positive. So in this case we can see that when 1 over n, so we will get actually answer 0. We know that something over infinity is actually equal to 0, so we will get answer 0. And when we get answer 0, so this is actually a first case. This means that our radius of convergence will be equal to infinity, and our interval of convergence will be equal to, open interval of convergence will be equal to minus infinity to plus infinity. So this is the first case, that is answer. So see that this will become a first case. We discuss about the three cases. So for in case if we get zero answer, this means that radius of convergence infinity and interval of convergence minus infinity. And second case, if we get infinity, then our radius of interval will be 0, radius of convergence will be 0, and interval of convergence will be equal to, that's only center. So, but third case, in third case, keep in mind we also have need to check it out at endpoints of the interval for finding the interval of convergence. We will take one more example. For example, like if we have something, let's say we have something like that, summation and start from 0 to infinity, and we have minus 1 raised to power n time x minus 2 raised to power n divided by 4 raised to power n. So if we have need to find the interval of convergence and radius of convergence for this problem, how we will do that? First of all, this is x. First of all, we can see that, and this is n. So we can easily see that the center of this series is minus 2. And now after this, if we have need to find the interval of convergence, so we will use ratio test. We know that an will be equal to x minus 2 raised to power n over 4 raised to power n, and I am ignoring minus 1 raised to power n because I know that when we will apply mode on it, so it will be equal to 1. So that is why if you ignore this minus 1 raised to power n, there is no issue. And a n plus 1 will be equal to x minus 2 raised to power n plus 1 divided by 4 raised to power n plus 1. If you take minus 1 raised to power n, there will be no issue. But if you ignore it at that point, because we know that we have need to take the absolute. So when we take the absolute of negative number raised to power n, and n will be a natural number, so if we always get 1, that is why I am ignoring here. So now we will apply ratio test. Limit n approaches to infinity, a n plus 1 over a n, that will be equal to limit n approaches to infinity. What is a n plus 1? This is x minus 2 raised to power n plus 1 over 4 raised to power n plus 1. And if we want to write it as in a multiplication form, I have need to take the reciprocal of this expression. So it will become 4 raised to power n over x minus 2 raised to power n. And when we will cancel out, we will get limit n approaches to infinity. And here on numerator, we will get x minus 2. And in denominator, we will get 4, right? So in this case, we can see that this expression can be expressed as 1 over 4. Like we know that mode of any positive number will be equal to itself, so it will be 1 over 4 and mode of x minus 2. Here there is no n, that is why limit will be, we know that limit of a constant number, like if x approaches to any number c and we have any constant number, so it will be itself k, constant number. So in this case, like this is the third case, see that limit n approaches to infinity, it will become actually third case. So in third case, we know that what will be our radius of convergence in this case? That one which is in our denominator. So our radius of convergence is 4. And what we have need to do, so we have need to set it out something like that, x minus 2 less than 4. We are interested to find the interval of convergence. That is why we will set it equal to less than 4. Now we have need to solve this. So it can be expressed as x minus 2 less than 4 and x minus 2 greater than minus 4. And if we want to find value of x, we have need to add 2 in this inequality. So when we add 2, so what we will get? We will get minus 2 here, and here we will get x, and this side we will get 6. Now see that our interval of convergence, this is our powers, like given power series, open interval of convergence become minus 2 to 6, right? But this is not the final answer. We know that for in case of like if third case become, we have need to check it out at endpoint. So in this case, endpoint is minus 2 and 6. So we need to check it out. We have need to check it out that either minus 2 be the part of interval of convergence or not, or either 6 be the part of interval of convergence or not. For this, what we will do, we will set this value of x in given power series, like we will put here and check it out that the given series converges or not. So see that when we put x is equal to uh, minus 2, so what will power series become? It will be minus 1 raised power n and start from 0 to infinity, and x is equal to minus 2. minus 2 raised to power n over 4 raised to power n. So in this case, it will become n start from 0 to infinity minus 1 raised to power n, and this will become minus 4 raised to power n over 4 raised to power n. And if we more simplify, we can see that it can be expressed as summation n start from 0 to infinity and minus 1 raised to power n, and this expression can be written as minus 1 raised to power n times 4 raised to power n divided by 4 raised to power n. So 4 raised to power n will be cancelled out 4 raised to power n, and we know that when the base is same, relation multiplication power will be added. So actually this will become n start from 0 to infinity minus 1 raised to power 2n. Now we know that if we have 2n and n goes from 0, 1, 2 and so on, if you put any number you will get these number. If you put 0 you will get 0, if you put 1 you will get 2, if you put 2 you will get 4. So we get even numbers. So this means that we know that when we have minus 1 raised to the power even number, it is equal to 1. So that is why in this case we will get constant number 1. So we will get constant number 1. So sum of 1 will be equal to like n 0 to infinity. So this will be actually finite. So this means that this like minus 2 will be the part of interval of convergence. Now we have need to check it out. Second endpoint x is equal to 6. For this, again we will do the same procedure. We will put x is equal to 6. So it will be 6 minus 2 raised to power n over 4 raised to power n. And here is n. So when we simplify this, we can see that it will become n 0 to infinity minus 1 raised to power n, and 6 minus 2 will be equal to 4 raised to power n divided by 4 raised to power n. So both will be cancelled out. We will get n 0 to infinity and minus 1 raised to power n. So this is alternative series, right? And we know that to check it out, that given alternative series convergence or divergence, we use this test limit n approaches to infinity. Here we will take mode of an. In this case, an is minus 1 raised to power n. So we know that this answer always will be equal to like limit n approaches to infinity as it is, and the answer of this part always equal to 1. So we will get 1. So this is also convergent, and if absolute series convergent, this means that series also convergent. We also have idea about that. So in this case, 6 will also be the part of interval of convergence. So if we draw on a number line interval of convergence, so what is center? In our given case, center is actually uh, 2. And if we discuss about the interval of convergence, so this is 6 and this is something minus 2. So we should need to take equal distance in both sides. It will be somewhere, let's say minus 2. So see that if we draw the interval of convergence, so we will start with closed circle on 6 and minus 2. So if we take any number between this interval, if we take any number between these intervals, so our series will be converged. And like if we don't take any value of x in this interval, like we take here, so our series will be divergent. So this is the interval of convergence. So this is a way out how we will find the radius of convergence and interval of convergence. We take one more example. Similarly, uh, similar nature. For example, if we take okay, if we take summation and start from 1 to infinity, and we have minus 1 raised to power n over square root n, minus 1 raised to power sorry, instead of minus 1, if we take x minus 1 raised to power n, or 3x minus 1 raised to power n. So this type of problem, how we will solve this? We have need to find the interval of convergence. First of all, center, interval of convergence, and radius of convergence. For center, we know that we will set x minus 3x minus 1 equal to 0 and solve for x. So when we solve for x, we will get 1 by 2. So this is a power series center about 1 by 2. Now for finding the interval of convergence or radius of convergence, first of all, an will be equals to what? 3x minus 1 over square root n, and an plus 1 will be equals to 3x minus 1, 3x minus, sorry, raised to power n, and 3x minus 1 raised to power n plus 1 over square root n plus 1. So in this case, when we apply the ratio test, an plus 1 over an equals to, this will become something like that. First of all, an plus 1 term. So limit n approaches to infinity, and we have 3x minus 1 raised to power n plus 1 over square root of n plus 1 times a reciprocal of this expression, so that is square root n over 3x minus 1 raised to power n mod. So see that it will be limit n approaches to infinity, and on nominator we will get square root n times 3x minus 1, because 3x minus 1 raised to power n will be cancel out this term. So we will get just 3x minus 1 square root n divided by square root of n plus 1. So if we see that 3x minus 1, like this expression, there is no n involved, so we can take out of limit, right? So we can write it as 3x minus 1 mod times limit n 1 to limit n approaches to infinity, square root of n over square root of n plus 1. And if we want to take, if we apply mode here, or if you don't apply mode here, there is no matter, because n is a natural number, so it will always be a positive, and mode of positive number is positive. So see that if we want to find the answer of this one, if n approaches to infinity, we have need to divide it by n square. Like when we divide n square on numerator and denominator, so it will become something like that, like 3x minus 1 limit n approaches to infinity. See that this n square can goes inside the square root, it will become n over n, and in denominator it will become n plus 1 over n. So this expression actually will become equal to 1. You can check it out that easily, like 3x minus 1, here is more, and this expression limit n approaches to infinity, and it will be 1 over, this expression will become 1 plus 1 over n. So we know that when we apply limit, so 1 over n will goes to 0. So we will get the answer like 3x minus 1, and this will be equal to 1. So there is nothing in denominator. This means that its radius is 1, right? In denominator, like see that in denominator there is nothing, like 1 over 1. So if you don't see the denominator, this means that its radius of convergence is 1. So what is our r in this case? First of all, see that limit n approaches to infinity, a n plus 1 over a n is equal to 3x minus 1 mod. So see that in this case our radius of convergence is 1. So what we have need to do for finding interval of convergence, if we find the radius of convergence, so interval of convergence easily find by 3x minus 1 set less than r, that is 1. This is the formula, like x minus a less than r for finding the interval of convergence. So that give us the open interval of convergence. So when we open this mode, we will get this less than equal to 1 and this minus 1. So if we add 1 on both sides, like whole of this inequality, so what we will get here will be 0, and in this place we will get 3x, and that will be less than 2. we need to find the x, so we will divide it by 2, so we will get uh, x, there will be 2 by 3. So this is a open interval. Now we have need to check it out that the end points of this open interval, that will be the part of interval of convergence or not. For this we will set first of all x equal to 0 in series. So when we put 0 here, what it will become? It will become minus 1 raised to power n, right? So see that summation n start from 1 to infinity minus 1 raised to power n. When we put x 0, it will become minus 1 raised to power n over square root n. Just give me a second. Yes, it will become minus 1. Sorry, here is no minus 1 raised to power n involved. So this will become, actually see that it will become 0 minus 1 raised to power n. That will be written as minus 1 raised to power. So nominator will be minus 1 raised to power n. Just minus 1 raised to power n, not twice. Just 1 second. So it will become actually minus 1 raised to power n divided by square root n. So we can see that here this is alternative series, because here we have minus 1 raised to power n. So for alternative series, we will apply always absolute test, like limit n approaches to infinity, and we have need to take the mode of this term, this expression. So see that this general term mode we have need to take minus 1 raised to power n over square root n. So we know that if we have a over b mode, we can write it as mode of a over mode of b. And if we take the mode of a, that is actually minus 1 raised to power n mode, which is always equal to 1. So this one actually will become limit n approaches to infinity 1 over square root n. And in this case we will get like 1 over n, this will be equal to 0. And we know that for absolute for alternative series, when we apply absolute convergence test, so in this case always when we get 0, this means that our series is absolute convergence. So if this is absolute convergence, so every absolute convergence series is also convergent. So this means that our given series is convergent. So if this is convergent, if this is convergent, this means that our for interval of convergence, 0 will be the part of interval of convergence. And second thing, we have need to check it out at x is equal to 2, 2 by 3. So when we put 2 by 3, 2 by 3 in this series, like in place of a, first of all, see that what it will become, 2 by 3 minus 1 raised to power n. So see that 3 will be cancelled out, 2 minus 1 will be equal to 1 raised to power n. So series will become like that. Summation n start from 0 to infinity 1 raised to power n over square root n. And we know that n 1 raised to power any number will be equal to 1. So this will be written as summation n start from 0 to infinity 1 over square root n. Now we can also write it as summation n start from 0 to infinity 1 over n raised to power 1 by 2. Now see that if we apply here p series test, what is p here? P is 1 by 2. So 1 by 2 is less than 1. If this is less than 1, this means that given series is divergent. Because p series state that if p greater than 1, then convergent. If p less than or equal to 1, then divergent. So in this way, our like this point 2 by 3 will not be the part of interval of convergence. So we will write it as open interval like that. And if we want to draw on a number line, it will be something like that. What is center? We find the center 1 by 3. Yes, 1 by 3. And let's say here will be by 3. And here will be somewhere 0. So in this case, 0 is the part of interval of convergence, so we will fill closed circle, and 2 by 3 is not a part of circle, we will put a open circle. So this is how we will draw on a number line. In the same way, if we take more example, For example, if we take more example like that, mm, like for example, if we have summation, just one summation and start from 0 to infinity, and we have n factorial and access power n. So how we solve this, how we find the interval of convergence? Same step. See that in this case we can easily see that x is equal to 0, or you can say that a is equal to 0 is the center of this power series, right? So this is center about a is equal to 0 or x is equal to 0. So now second thing we have need to find in radius of convergence and interval of convergence. For this, what we have need to do, for this we will consider an, that is n factorial access power n, and an plus 1 will be equal to n plus 1 factorial time access power n plus 1. So now we apply ratio test, that is limit n approaches to infinity a n plus 1 over a n. It will be written as limit n approaches to infinity. What is a n plus 1? A n plus 1 is n plus 1 factorial x is power n plus 1 divided by an, that is n factorial x raised power n. So we can see that it can be written as limit n approaches to infinity n plus 1 factorial. We know that this is a property of factorial. If you have n plus 1 factorial, you can write it as n plus 1 times sorry, we can write it as n plus 1 times n factorial, right? So in this way, it can be written as n plus 1 times n factorial, and here will be x raised power n times x because the power added here, and divided by n factorial x raised power n. So here common terms will be cancelled out. So we can see that x raised power n cancel out with x raised power n factorial cancel out with n factorial, and we will left with limit n approaches to infinity n plus 1 times x, like this. And we know that x can be out of the limit because there is no n involved in this case. So n approaches to infinity will be written as n plus 1. So in this case, if we apply the limit, we will get mod x time infinity, that will be equal to infinity. So see that this is the second case, like limit n approaches to infinity, a n plus 1 a n will be equal to infinity. So whenever we get infinity, we become very happy because in this case we don't need to check it out and end points, we don't need to solve the absolute. So in this case our radius of convergence will be equal to 0, and only like interval of convergence only contain the center. What is the center of this series? 0. So you can say that given series is divergent except one point, that is its center. So at 0 this is convergence, but if you take any value other than 0, that will be divergent. So this is a style of saying, you can say that given series, given power series is divergent except x is equal to 0, or you can say that given series is convergent just only x is equal to 0. So this is your own way to define like convergence or divergence. So now we will take one more example. Let's say we have we can consider, let's say we have n factorial and we have 3x minus plus 9 raised to power n, and summation n start from 0 to infinity. How we will find the interval of convergence and divergence, and what will be the center of this one? For finding center, we have need to solve this if expression for x. So when we solve for x, we will get minus 3x is equal to minus 9 divided by 3 on both sides. This means that x is equal to minus 3. So this is a power series center about a is equal to minus 3, right? Now see that what will be the an? An will be n factorial times 3x plus 9 raised to power n. And what will be a n plus 1? That will be equal to n plus 1 factorial times 3x plus 9 raised to power n plus 1. By ratio test, limit n approaches to infinity, a n plus 1 over a n will be written as limit n approaches to infinity. And see that what is a n plus 1? A n plus 1 is actually n plus 1 factorial times 3x plus 9 raised to power n plus 1 divided by n factorial times 3x plus 9 raised to power n. And we will get, after simplification, limit n approaches to infinity, we will get n plus 1 times 3x plus 9, this expression. And this can be written as 3x plus 9 mod here, and limit n approaches to infinity, mod of n plus 1. So when you put the value of n infinity, we will get 3x plus 9 times infinity, that will be equal to infinity. And again, in this case, this is a second case, like when we solve ratio test and we get the answer infinity, this means that our radius of convergence will be equal to infinity, and interval of convergence will be its center. What is the center of this one? We find the center -3. So you can say that series is only convergent for its center, x is equal to -3, or you can say that given series is divergent all the points except x is equal to -3. So this is how we solve the power series, how we find the center of power series, how we find the radius of convergence and interval of convergence. I hope you better understand this. If you have any question, you can contact me here. I will be available. And if you want to book a session, I will be available to you. Thank you so much. Have a good day ahead.